Good morning, everyone.
Good morning, ma'am.
Yeah. So, guys, uh, today we are here to attend a webinar on mathematics in ML, which is an hands-on session on regression analysis. So, dear colleagues, students, I am honored to take this opportunity to welcome all of you for this one-day live webinar. So, which is a hands-on session on regression analysis organized by the Department of Mathematics, RMVIT, Bangalore. So, first of all is we will be having questions like when you see the topic that we have here is what mathematics is doing in regression analysis or artificial intelligence, etc. Right? So, when we look into the machine learning, machine learning is all about creating algorithm that can lead data to make a prediction. So what does this machine learning does? It helps us to it helps basically Amazon to suggest products for us, YouTube to recommend videos, etc. So this machine learning is structured on four pillars of mathematics. They are linear algebra, calculus, statistics, and probability. So when I speak of statistics, obviously, how can I miss regression analysis, which is the very basic concept of statistics? So what we decided was, let us have a hands-on session so that students and faculty, that is us, know what does the regression analysis role in machine learning. So with this brief background, I would like to welcome faculty, student, resource scholars, and our research person Arif Nawal, lead technical writer, Diazonic Labs, to this webinar. I would like to extend my gratitude towards our principal, Dr. Via Manjunath, Dr. S.K. Uma, HOD, Department of Mathematics, Vasudha, organizer of the webinar, and our department fellow colleagues for encouraging us to conduct a webinar of this kind. So I'm sure that you all will feel enriched with the knowledge after completion of this webinar. I welcome you all once again to the seminar. Thank you. So guys, now today's resource person we have here is Arif, and I would like to introduce himself, and later he will be taking over the session for the day. So Arif Nawal is a lead technical writer, Diagnostic Labs, and his areas of expertise are he is a trainer and he has hosted programs by the Diagnostic Labs, included embedded systems and IoT using Nude MCU, basics of Python, machine learning, artificial intelligence, deep learning, data science, cyber security, and cloud computing. So Diazonic Labs has hosted many live webinars during the pandemic, and they have trained more than 2,000 students, faculty, and working professionals. So recently, a part of training program for the students of Wellington University has hosted
Okay. Thank you very much, ma'am, for the introduction. Good morning, all. This is Arif from Diazonic Labs. Hope you all are doing good. And I'm actually honored to be here and take this session for you all. So we just hope that we'll have a great time and then you learn something new. Right. So our topic for the day and topic of discussion here is going to be the mathematics which is involved in machine learning. Right, so we'll learn about one of the algorithms in machine learning and see how it works, right? So what is the logic behind it? What is the math behind it? And then we'll just have a look at it. Yeah. So can I just get a quick confirmation if I'm audible perfectly? If you're facing any issues, just
Yes,
let me
yes, sir. Audible, sir.
know. Audible, perfect. Okay, so one more small announcement is that if you are not able to join via the Google Meet links, that is, if your friends have registered and are not able to join, we also have a link that is going live on YouTube because Google Meet has a restriction on their participants. Right, so only the first 100 are able to join. The other people can join on our YouTube link, and any queries you have, you can put it in the chat there or here. Right, so we'll take both queries from both the places, but then I would request you to keep the queries for the last half an hour, right? So unless and until very important, please try to keep your queries at the end. Okay, so let me just begin. Just give me a few seconds. All right, so I hope you can see my screen and the presentation. Right, so
Yes, sir.
yeah, thanks. So beginning with our topic for the day, it is machine learning. And some of you might have heard about this, some of you might not have heard about this. Not to worry, we are going to go at a very beginner level, that is so that it helps all of us, and then we will understand the maths and the logic and working behind it. Right. So first of all, what is machine learning? Right. Can you all use the chat to actually share your thoughts if you know something about it? Right. So it'll be easier for us. Right. Anyone has any idea as to what machine learning is? Have you heard of this term before?
Yes, sir.
Yeah. Just request you to use the chat, please, because the volume and things might just become a problem for others. Okay. We can have predictions of future event. Okay, through data analysis and all those things. Fine. Okay, I've got one answer. So let me just tell you with a simple definition. Machine learning is a study of algorithms that improve the experience, and as and when we train our data, it becomes more smart. We create a machine learning model, right? So it is a part of artificial intelligence. Okay, here is a small representation of what has it got to do with the math and thing which we are studying right now, right? So computer science, we need to have a little bit of computer knowledge, and applying of machine learning algorithms along with the maths and statistics, which is the most important part of machine learning and data science, and then along with the domains or business knowledge forms the data science, right? So the whole thing here, the machine learning is a subset of AI, and then it is related to data science. So we have got a lot of maths and statistics involved, right? Okay, a proper definition here, it is a subset of artificial intelligence which provides machines the ability to learn automatically and improve from prior experience without being programmed again and again, right? So all you need to do is take some data, train your machine, create a model, and then predict the outcome. That is what we are going to do in machine learning. Now, here the data input can be either numbers, text, image, videos, or audios, right? So this is the data input which can be that. We can take any of these things. Okay. Now, how does it work? What is the difference between a ML algorithm and a normal program? So the language used most commonly for machine learning is Python. So I've just got one example here, right? So we take data, whatever is the data we have, to write a proper program. We write a program using this data, and then we are going to type the program in our systems and we'll get the output. So this is how a simple program works. For example, if I take a Python program, right? This is a program for one of the functions. Def here is for a function sum a comma b. If I want to print the sum of a and b, I write it like this. And then finally, I get the output as 6. Right? So this is the program. This is the data. And then this is the output. So this is how we normally do programming. Right. Now, what happens in machine learning programming? You've got the data. You will also have the output at the very beginning. And then we combine both of these things, inputs and outputs, right, to create a model. Now, I am creating a model. This is my model, right? On my computer, I am trying to create a model. And then how am I making it smart? I am going to again feed it back, right? So it's going to create, the model is going to be updated every single time I make some change, right? So I can update my model and make my model more smart and make it more useful, right? So in machine learning, your model learns from previous data, finds insight, that is, if any differences is there, it finds that, and then we train the model and it grows with increasing accuracy. Accuracy increases every time you update your model, right? So you can do that. You've got that option, right? So this is how machine learning programming works. All right. Now, machine learning is split into supervised learning or unsupervised learning, right? We'll just see this in the next slide. After this, in supervised learning, we've got something called as regression. And this is exactly the thing which we'll be learning. But just for information's sake, I'll just tell you what are the other things which are available. There is also classification technique. And then in unsupervised, there is something called as clustering as well, right? So our topic of interest is regression. Now, for understanding regression, we need to know what is supervised learning. Right? Here is an example. I've got input data, or you can also call it as simply data. And then this data is given to an algorithm, that is, if it is regression or classification, I'm giving it to a regression algorithm in the supervision of a person. There is one person who is supervising here. In presence of this person, we are feeding our data to the algorithm, right? Then we'll do a few steps for processing and pre-processing. And finally, we will get our model. I'm training my model. After I get this model, here, the apple which you find, initially we have trained our model to use the red apples, using the red apples. Now, if I show the model a green colored apple, it will tell me that it is an apple, right? So this is what machine learning does. We are training it to be here for red apples. If I give a green colored apple, it will tell that it is an apple. So we'll take an example as to how this works in real life. Say, imagine I am attending a class. What have we taught in our lower grades? That is, when we start learning in, say, first, second standard, or even before that, say there is some teacher who's telling us about 1 and 2 and 3. So he or she tells 1 plus 2, right? So this is what is being taught to us. 1 plus 2 is equal to 3 and 2 plus 4 is equal to 6, right? So this is the thing which is taught to us in class. Now what happens in an examination? We get a question telling x plus y, which is 10 plus 15 equals to how much? Now, how are we able to guess the output here? Because we know the output for 1 plus 2 and 2 plus 4, we are able to tell the output for 15 plus 10 or x plus y, whatever it is, right? So we are learning before, and as a result of that knowledge which is stored in our brains, we are able to answer this. Right? So what if I directly go and give you a question for 10 plus 5 to a grade 1 child or LKG or UKG child who has no idea about addition of numbers, right? So he or she will not be able to do it because haven't been trained. So the same logic applies here, right? So that is about supervised learning. Now coming to the supervised learning, I've got another example. So if you have got the shapes here, these are my inputs and these are the labels which were there. So this is a hexagon, a triangle, and a square. We create a model, right? Training a model is done. And after the model is created, we try to predict the values, right? So if you see, I am giving a square and a triangle here. So if I give this data to my model, which I've just created, it will tell me that this is a square and this is a triangle, right? So the data here, we call it as well labeled because we've got labels for all of the data, right? So this is how supervised learning works. Examples, classification and regression. Coming to the unsupervised part, we'll take an example of Tom and Jerry. Right, so we've got 6 images here. This is unlabeled data. It is not written anywhere that this is Tom or Jerry, right? So unknown output and unlabeled data. So there is no output, only input part is here. Now, we create an algorithm, that is, we create a model using an algorithm, right? In unsupervised, I told you there is something called as clustering, right? Clustering algorithm is applied and we create a model. In this model, what it does is it is going to split into 2 clusters, one cluster for this, one cluster for this, based on feature of similarity, right? So whatever it finds similar, it is going to form a cluster, right? This is what happens in unsupervised learning, right? Another example for supervised is if I've got 2 ducks and 2 not ducks, right? So you have the images as well as the labels. If we perform supervised learning, we get a model. Now I will take a third type of duck and then I ask my model, what is it? It will give me the output that this is a duck. This is what happens in supervised. Coming to the same example for unsupervised, that is in clustering, I've got 5 different images which has 1, 2, and 3 types of ducks. So it is just going to form clusters for ducks, 1 cluster, for the other 2 animals, 2 different clusters. Right? So I hope you have all got the idea about what is going to happen. So I've just got a difference table here. Need not worry much about it. Just in case, you can have a look. Right. Now we'll come to the topic. Linear regression. Right. In statistics, how do we define linear regression? It is a linear approach to modeling the relationship between a scalar response and one or more variables. Like one or more variables here are dependent variables or independent variables, right? So we've got 2 types of variables here. Now, this was the technical definition. Now, to come and give you a more simpler definition, a linear regression line is something like an equation which we use that describes a relationship between independent and dependent quantities, right? So we get 2 quantities, that is our x and y. So x is input and y is output, right? So these are the 2 quantities which we are using. Okay, so we'll just discuss one example right here. All right. So why do we use linear regression? It is useful for finding relationships between two continuous variables, right? So initially linear regression was developed in the field of statistics, right? And was studied as a model for understanding the relationship. But then now it has slowly been integrated into the machine learning models as well, right? So the example here is the equation y is equal to c plus mx, or y is equal to mx plus c. So I hope we have all studied this equation. This is the equation for a line, right? So how can we find this line is what we are going to learn. So here is an example of the graph which we use, right? This is the graph, and here we've got dependent variable and independent variable. So this value is x, or input, and this is y, right? So if you can see y here, it says that it is dependent, and then x here you can see that it is independent, and this is going to be the thing for input, this is going to be the thing for output, right? So in this equation we also have m, which is the slope of line, and we also have a c, or the constant, which is also called as y-intercept, and this is called as coefficient, right? So now how does it work? We will take one example and then go ahead and see how this thing works. Okay, now the equation for finding m, or the slope of the line, is this: x minus x bar into y minus y bar whole divided by summation of, again here also summation, x minus x bar the whole square. This is the equation for m. Right, now what is x bar? It is mean of x, and what is y bar? It is mean of y. Right, so we will actually find all these values taking one data set, or taking some data from an online source, and then perform all of these operations, right, to find the c value, to find the m value when we know x and y values. Right, so let me just come back. I will just go to the hands-on part straight away. Just give me a second. Okay, so now let me just open a new window, right? And I've got a link for you all. So from here, I want you to download this file, right? So I'll share the link in the chat. Right? I'm going to share the link in the chat. Right? So this is a link for bit.ly 3dmbtqy. Right? So this is the link, and right. So from this link, I will actually be able to download the data set, right? So from this link, I can actually download the data set. Okay, if you can see here, this is the link, or this is the data set link which I've got. It says that it is salary underscore data dot csv, right? So this is the link which I have. All I want you to do is download the data set from here. We've got an option to download. Just want you to download the data set. Right, I'll just click on this thing, download. Right, so it's a drive link. I want you all to actually download from here. Okay, now that I've downloaded the salary underscore data dot csv, right, using a laptop at this time would be preferred, because we will go only to the hands-on part. Right, so I've got the two columns here. called as years of experience against salary. So what this data set tells us is that if a person has this amount of years of experience, like if a person has 1.3 or 2 years of experience, his or her salary is estimated to be around 43525, right? Similarly, if a person has 3 years of experience, his or her salary is expected to be somewhere around this, right? So this is according to the data set which you have got. I have taken this data set from an online website called as Kaggle. It's there, all the websites and all the data sets will be available for us to perform machine learning algorithms, right? So this is the data which we want. I hope you all are able to download this from the link which I just shared. Right, now what am I going to do with this data? We will perform a regression analysis using this. So I'll just open the Google Sheets, right? So let it be online, and I'll just open Google Sheets here, a new spreadsheet. Right, I'm just creating one new spreadsheet. This is how you actually access a Google spreadsheet. Just go and give docs.google.com/spreadsheets, and then you will be able to access. And I'll share the link for this as well. Right. So I've got the Google spreadsheet, and we are going to do all the analysis on Excel first, right? So if this is my CSV file, I've got years of experience against salary, right? We'll take this as X and this as Y, right? So salary is Y or output. This is years of experience is X or input, right? So this is the data. What I'll do is I'll just copy all of this. I'll copy all the values from here and then go paste it here, right? So in my spreadsheet, I will just go and paste here, right? So what happens now? I've got all the values, that is 1.1, 1.3, and the other things, right? So I will also go and share the other things, that is the other column as well from my Excel, right? So this is my salary. I'll take all the values in salary as well and then paste it here, right? So I've got my X and Y. After getting X and Y, now I need to actually perform the operations, that is find the values for Y is equal to mx plus c, right? So find m value, find c value, right? So how do I do that? I will just name these columns. Let me just name these columns as X and Y, and next is what I will do here called as X minus X bar. Okay, I'll just take a minute. Are you all understanding? Am I going too fast or am I too slow? Right, so have you understood how to download the data set and how to open a new spreadsheet that is using Google Sheets and then copy the data here, right? Can you just get a quick confirmation? Just give a yes if you have understood and are okay with it so far. Okay, so I've got the values here, that is of X and Y. right? So what I'll do is now I will come to the very bottom, right? I will come to the very bottom of this, that is cell number 32. And then I want to find the average of all of these things, right? So I want to find the average to find the X bar value, right? How do I find X bar value? I will find the average. And to find the average, we will use equals to, right? We will use this particular formula, equals to average of A2, right? So I just want the average for this value, which is A2, and I also will give is to A2 is to A31. Ready? So it is A2 is to A31. So this I'll just give a enter, and then it is going to give me the average value. So as soon as I give this, I will get the average value. Right? You can just have a link. Look here. It is average of A2 is to A31. Right? So I'll just wait for a minute so that you all can actually do it. Okay, so this is the command to find the average. Okay, now I've got 5.33 as the value. Now what is this 5.33? This is the X bar value which I've got. Right, so let me just zoom it in a little bit so that's more visible. Okay, now this 5.33 is my X bar value, right? So I'll just write it as X dash. Here, X dash. And I'll just change the color for this so that it is easier for us to have a look at. Okay, so I've got the X dash value. Same way, I also need to find the values for Y dash. So same steps, come here and then give equals to, and then give B2, which is the first value in this column, and select the values all the way to B31, right? So you can see that there is a dotted line coming starting from here to here, right? So I need to find the average of all of these values. So this is how I find the Y bar, right? So it says, I'll just give a reject suggestion. I'm getting the Y bar value now, right? So I've got the Y bar value, and let me change the color for this as well to yellow, right? So I think this is a little more visible and a little more clear, right? So we have got X bar and Y bar values. Now coming back to the PPT, we have got X values, we have got X bar values, we have got Y, and then we have also got Y bar, right? So now we need to have this term as a whole, X minus X bar into Y minus Y bar, as well as X minus X bar whole square. So we need to have the values for these as well, right? In order to find the M value. So we are working on this. Right, let me just go back to my spreadsheet. I've got X and X bar, Y and Y bar. So my next column is going to be a new column called as X minus X bar. Right, so I've taken something called as X minus X bar. So what I need to do is I need to take X value, which is 1.1, and then give minus 5.3. So this is going to give me somewhere around 4.21, right? How do we tell Excel to do that? I just give equals to, right? I'll just give equals to, and instead of writing 1.1 or anything, I will just give the cell number. This cell is cell A2. Right, so this is cell A2 minus what was the cell for 5.31 or X bar? It is cell A32. So I give minus cell A32, and then I'll just give a enter. Right, so as soon as I get this, it is going to give me the suggested autofill. I'll just give reject suggestion. Right, so A2 minus A32 is going to give me the correct answer. But then what happens if I actually drag this down. So generally what happens is if you drag it down, it will apply the same logic and then give you the values. Right, but then here it is going to give me an error, and after that it is going to give me the same output, which is not the correct answer. So we want it to subtract 1.1 minus 5.3. Again, 1.3 minus 5.3. What is the cell number of 5.3? It is A32 here. Right? But then if you have a look here for 1.5, it is going down. It is going to A4 minus A34. So this value should not change. It should be logged at A32, like here. So what I can do is I'll just delete all of these things and I will click on this and then I will give F4. Right? So as soon as I press F4 on my keyboard, it is going to lock the values. It puts a $sign here. Right, so it puts a dollar symbol at A as well as 32. Right, so it is going to lock for the values at A32 itself, so that it doesn't take A33 and A34, A35 here. Right, so I'll just press enter. This value, there is going to be no difference, but if I just do scroll down and select all the other values, you can find that for the second value also it is at A32 now. It is not changing to A34. Right, so you can see that everywhere it is just A32, so that it is taking the reference of A32 and then subtracting it from A2 or A3 or A4. So 1.1 minus 5.3, 1.3 minus 5.3, 1.5 minus 5.3, 2 minus 5.3. Right, so this is going to give us the values for x minus x bar. Right, so far what have we finished? We have finished this term. Right, now we'll just come back to it and then we will scroll to the next part. That is, I need y minus y bar. I think you all can do this now. Right, I want you to try this on your own. Right, you can just have a look at what I am doing and try to do it on your own. So if you have a look here, I've got y minus y bar. So I've got y values, which is 39343 minus, what is my y bar? I have to come down. It is this cell number B32. 76003. Right, so I will apply the same logic which I used here. Instead of giving A2, I will give B2 because y is starting from B2. So I will give equals to B2 minus of, what was the other thing? It was B31 or B32 rather. So I'll give B32. Right, so this is the only thing which I need to do. I will press an enter. Right, now again in the autofill, if I just do, it is going to give me an error here and then give the same values here. 43525, 3989 and then 566 and all of these things. Right, so all of these are incorrect values because we have not logged it. So I can just cancel this, go here, click here and then press F4 so that it locks the value at B32 itself for y bar. Right, so this is the value which I've got. B2 minus B32 is the cell which we have, and then I get a value of minus 36,000. Right, similarly I'll just drag it to the very bottom, that is still here. Right, so in any place if I have a look, it is constant at B32 because this cell is locked. This particular cell is locked for all the values. So if we just try and see what is B2 minus B32, just showing you 39343 minus of 76003. 76003. Right, so it is going to give me 36,660. Right, so this is the y minus y bar value which I've just got. Okay, so we've got x minus x bar, we've got y minus y bar. That is the two of the things in the numerator. But then what we want is we have to multiply both of these things together. Right, and then take a summation of all the values. So how do I multiply x minus x bar and y minus y bar? Very simple. Come back here, multiply the entire C column with the entire D column. Right, so I will take one more thing here called as x minus x bar and I am going to multiply it with y minus y bar. Right, so this is my next column. Okay. Now, how do I actually do this? Very simple. I just need to give C into D. So I will give equals to, and then I will give C. I don't want C1 because if I take cell C1, it is going to refer to this. I don't want this text. I want it from C2. Right. So I will take C2 and then I will multiply it with D2. Right. So it is showing us the reference here. This multiplied with this. Minus 4.21 into minus 36,660. Right. So it is just going to give me this value. Minus into minus is plus. So I've got a positive value for 15,000 or something. 15,004, or I think that's a 1,54,000 value. Right. So this is the thing which I got. Now, this was for our x minus x bar and y minus y bar. Can we apply the same logic in here? Can I just click and drag this to the very end? Right, to cell 31. Right, here there is no need to lock because we want the values to change from D2 to D3 to D4. Right, so we want C2 into D2, B2 into, this part. C2 into D2, C3 into D3, C4 into D4 for the value here. So exactly what is happening here. For example, if I take C10 and D10, here it should be equals to C10 into D10. Right? So we've got the perfect values here for all of these things. And this finishes x minus x bar into y minus y bar part of the cell or the column. Now, we've pretty much got our numerator, but then the summation part is still left. We've got the multiplied values. Now, how do I actually give the summation? Right, so I come down to the very last thing. Right, I will give equals to, and then I will give sum, capital of sum, and in brackets, I will mention the range that is starting from E2. I have to give is to E31, right? So starting from E2 is to E31. This is where we want to find the sum values, right? So it is taking all the values from here to here, E31, and then giving us the output. So you can see the range here, E2 to E31, and then giving us the output, which is 2207082.8, right? So this is my output. So I'll just put in a different color for this. Okay, so this value is my numerator. X, I've got the numerator value in here. What is my numerator? Summation of x minus x bar into y minus y bar. Now, to find x minus x bar whole square in the denominator and take a summation for it, I will take another column, one final column. So here I will give x minus x bar into y minus y bar. Right? So how am I going to find this value? Sorry, it is again x minus x bar here. My mistake. X minus x bar. So this is actually summing up or multiplying to give x minus x bar the whole square. So what I need to do here is just instead of multiplying C2 with D2, I can directly multiply C2 into C2. Right? So what is this going to give me? Multiplied value for this 4.2 square is somewhere around 16 and 17, right? So 4 square is 16, so 4.2 square is 17.7, right? So this is the value which I've got, C2 into C2. So again, I can just drag it down here till this point so that I get all the corresponding values, C3 into C3, C4 into C4, and so on. Right, so we are not giving the F4 command here so that we don't want to log the values. We want it to go to the very next thing. Right, so here 0.81 square is 0.66. So 8 square is 64. So 8.1 square is somewhere around 66. So we've got the values here. Okay, now again we need to find the summation for this. Same steps, just give sum, come here. Whatever I've used here, instead of the column, the values being E2 is to E31, here it will be F2 is to F31. Right, so I'll just give is equal to summation of F2 is to F31. And then let me just give a enter. So I've got the value as 233.55. Right, let me just do this. And we've got a denominator. Right, so I've got a denominator, numerator and denominator. Now the question is, how do I actually find the m value? Right, so I'll just give m equals to, or before that, I'll just type the equation. So our equation is y is equal to mx plus c. Right, so this is the equation which we were going to do. So how do I find m? I'll give m equals to, and let me just calculate it. How do I calculate? I need to divide this value by this value. So m is equal to numerator value divided by denominator. So the cell referencing for this is supposed to be E32 divided by F32. Right? If I'm not wrong, this is the value which I want. So let me just press and enter. Right? So this gives me a value called as 9,449 point something. Right? So this is the slope, or we can also call it as coefficient. Right? So this is the slope value or the coefficient value. Okay. So I'll just put this thing in green. And this is our final output. So I'll put it in this color. Okay, so this is my m value. Now, if I've got the m value, if I know the y values and x values, how do I find the c value? Right? So y is equal to mx plus c, which means c is equal to y minus mx. Right? So it has c is equal to y minus mx. Fine. So I've got the m value. Now to find the c value. Let me just give c equals to here. C equals to, and then just write a line it. Right. Here I will refer to the cells equals to B32. What is my cell B32? It is y dash. Right. So it is y dash minus, what is my m value? The cell for m is E37. Or I think it is E37. Yeah, it is E37. Minus E37 because it is y minus m, and into x. Right, so I'll give into x. Let me give into x value here is at 832. Right, so this is how I actually find. So this is my into x. Let me just give a bracket for this, and I'll tell you what is the formula I've taken here. Right, so B32 is this cell, y dash minus of E37 is this cell, which is 9449, into 5.31 is A32. So this is how I get my C value. Now I'll just put in the formula for C also here. C equals to y minus mx. Right? So we know how we got this. Just send the mx to the left part and then keep C here. So I get C is equal to y minus mx. Right? So here is my m value. Here is my c value. We call this as slope and coefficient. Right. So what am I going to call this? I call it as intercept. Right. So this is my intercept value. Just give me a second. Okay. So we've pretty much got the values for y, m, X and C as well. So all of the values are here. And this is the logic behind finding the equation of a line. So we've successfully found the equation of a line and found all the things. We were supposed to find M. We were supposed to find y-intercept, that is C also. We found both of the values. Now, using this logic and using this statistics, using this math, if I actually apply it in a machine learning algorithm, I will be able to get a linear curve. This is a linear regression line, right? This is what happens in a linear regression line. I've also got one example for this. We'll just try. Okay, it is just linear regression calculator. All you need to do is search for linear regression calculator in Google, right? So this is also for our participants watching us live from YouTube as well as Google Meet. So I just want you to do this. Now, before I actually get into this, is it part clear? Were you able to understand? Can I just get a confirmation saying that yes? If you have understood, just respond with a yes in the chat, either in YouTube or in Google Meet. Both of you can just respond. Right, so we've got, yeah, I want all of you to just give a yes. Come on. It's just one-way traffic. I've been speaking for a lot of time. Come on, you just respond with a yes. All of you that are in the meeting. Yes, yes, yes. So I've got a lot of yeses. In fact, there are still many more people. Come on, it's just three simple alphabets. Just put in that thing in the chat. Yep, great. Right, thank you. Thank you all for responding. Right, I am hoping that you have all understood what I wanted to convey. Right, so this is the equation of line, and then we've got the values. Now, how does this work in a linear regression is where we calculate online. So there is this thing online called as linear regression calculator. The website is called as socsci statistics.com. Right, and in here you've got test regression. Just search for a linear regression calculator in google.com, and the very first link, which is socio-statistics, you will have this option, linear regression calculator. Right, fine. So what we'll do is we will take our same exact data and then put it here. So it is asking us for X values and it is also asking us for Y values, right? It says linear regression calculator. This simple linear regression calculator uses the least squares method to find the line of the best fit for a set of paired data, allowing you to estimate Y values from independent X values, right? So the line of best fit is described by y is equal to bx plus a, which is y is equal to mx plus c line. So I'll come to all of that things here. They are writing it as y is equal to bx plus a, but we will take the traditional way. We will name it as y is equal to mx plus c itself. Right. So what I need to do now is I want you all to go to your spreadsheet. That is this spreadsheet, and copy all the x values. Right. So just like how you did it from the CSV file, just copy all the x values here from 1.1 to 10.5. I don't want the 5.3 or the 76K or anything, right? I want that. Yes, I will just give a control C here and then let me go into this part. Right, so I'm taking it back to the linear regression calculator that is in this website. Right, so I will just paste all the values here. Just give a control V in the X values and then you can find that we've got all the values in the same type, in the same order, right? The order won't change. In the same exact thing, it will be here. Again, let me just repeat. Just go to your spreadsheet, click on this, select all of the values, not the 5.3. Just give a control C here, come to this part, just give a control V. So we've got all the values here. Similarly, I will also do it for the Y. Right, so I just select all the values from Y and give a control C and then paste it here. Right, so this is my Y values and these are my X values. Right, so what I need to do here is just give calculate the regression equation. Just give this part and then wait for some time. Right, so as soon as I give calculate, you know what we got here. So it is giving us Y is equal to M into X plus C. We'll try matching the values. Let me just take this entire equation and then go back to the spreadsheet which we just did. I will paste it here. Right? If you can identify or find, it is Y is equal to M. M value is 9449.96 into X. X value, we know that there are so many things. That's why it is giving X. Plus C value is the intercept value which we got, which is exactly the same thing which we have got. And in fact, we have got it with one more accuracy, that is in the decimal points. We've got extra one thing. Right? So this proves that whatever we did was correct. Right? Now we'll see how it is calculated. Before I show you the graph and the other things, I will show you this. So this is my X minus X bar. This is my Y minus Y bar. X minus X bar into Y minus Y bar. X minus X bar whole square, right? All the things which we did here, X minus X bar, Y minus Y bar, X minus X bar into Y minus Y bar, X minus X bar whole square, right? So all of the calculations are here. You can just go and cross check whichever value you want. You will get it exactly same, right? And they've also given the final values, the sum and then the averages for all of these, right? So that is giving us a summary in here. A summary inside this which shows the calculation. Sum of X is this much, sum of Y is this much, and then mean of X is this much, mean of Y is this much, right? Then all the sums, that is taking the entire value, then the regression equation, and what is the slope, and then the C value, and then finally the equation. Right. So this is all the calculation and the math. Now, according to this, what is happening is, it is drawing a line. The blue line which you find is the regression line, which will be drawn as a result of all of these things, right? We'll see this practically. I will show you the same thing also, right? So a regression line will be drawn, and then we have got all of these values. What are these yellow color boxes? What are these yellow color boxes? Are all the values which were there from our X and Y, right? So these were the values, that is 1.1 corresponding to 39343 is going to show somewhere here. This is the point for 1.1, 39343. Right, so I've got all the 31, 32 values, and then according to my model, the best fit line is the blue colored line. Right, so this is how it works. Now we'll do a hands-on for this also. We've seen it in Excel. We will actually use the machine learning algorithm and then demonstrate. I will actually show it to you. Right, so now again, I don't want you all to download anything. We will be doing it on cloud, right? So we will be doing the same thing on cloud. I think you all have heard about this thing, ML Azure, right? So you all know what is Azure, Microsoft Azure, right? So I hope you all know what is Microsoft Azure. If not, let me just show you this thing. If not, Azure is a cloud computing platform, right? From Microsoft. And then you will have many services, many things which you can do on cloud, right? So I'm just bringing a little bit of cloud computing also inside here. Right. Now, what is that got to do with what we are learning, right? So there is a super link inside this, which is using Microsoft Azure, you can actually create your machine learning models, right? Using all the stats and all the maths and everything, you can do everything on cloud. You need not have any other thing, and all of these things without any programming language. Say if I am a beginner and I don't know Python programming, I don't know any programming, right? Even then, I can actually use and create a linear regression model. I can create a machine learning model because it doesn't require any programming. It is just drag and drop, right? So it is that simple. Now for that to be specific, I have to go to the ML Azure Studio. Right? So this is my ML Azure Studio. This is where I will actually be going. Right? Just give me a second. Okay, now pretty much everyone might be having your Microsoft Azure accounts or Microsoft accounts to be specific. You all have Microsoft accounts, right? Your Microsoft Teams or your own personal account, any of those things. So do you all have Microsoft accounts? So all you need to do is just log in with your Microsoft account in here. Can I just get a confirmation if you have your Microsoft accounts? Right, I've just posted this thing. Right, what is the Azure ML Studio? Right, let me just put it in the chat. It is ML Azure Studio. This is where we need to go. Right. And I just have to give studio.azureml.net. Now this is completely free of cost. We need not register, we need not pay or anything. Only thing which you require is you need to have a Microsoft account. Right? Why? Because cloud computing, the other things are paid up to a certain extent and everything, but for machine learning, it is completely free. Now what is this Azure machine learning? It is a GUI based, which means that there is no programming. It is only graphical user interface based integration development environment for constructing and operationalizing machine learning workflow or creating machine learning models on Azure. So I'll just open this and I will just go to this part, right? So it says, no, it is free. Welcome to Machine Learning Studio. It is free, right? What you require, you can just have a Microsoft account. You can have your school account or any other account, right? All of these things you can just do. You have the documentation and all the videos and everything for you to get started and refer and everything, right? So I'll just sign in now. I will use my personal email and then sign in inside here. And so it's just going to sign in. Now for you, it might ask you to log in, but then since I have only one, it is directly asked me to sign in, right? I'll just wait for 1 minute so that you are able to log in. Just give me a confirmation once you finish logging in, right? Just log in with your Microsoft account in here and then you are good to go. And I'll just wait for 1 minute and then take up any queries if you have until here, right? If you want me to repeat something and how to open the Azure and then log in or anything, right? Just here, I'll take 1 or 2 minutes for the questions as well. Meanwhile, you can log in and be ready on this page. All right, do we have any questions? Or are you good to go? Are you on this particular page? Right here. Or are you facing any issues? Right, okay. Piyush Raj Singh says, yeah, okay, perfect. Any responses in here from the participants in Google Meet? Okay, thank you. Yeah. Fine. So now what I need to do is, okay, Aman says, yes, perfect. Okay, what I need to do is, I need to go to the data sets. Right. I'll just delete this part. Okay. She also says yes, perfect. Right. So for you, if you are on all of these things, you have got something called as projects, experiments, web services, data sets, your previously trained models, and settings. So first thing is we will go to data set. Now you can just have a look here. It is called as a free workspace, right? So it's just free for us to use. Now in data sets, you will not have this. It will be a blank, right? So I will just go here and then I can click on new, or directly I can go to experiments, and you will not have any of these things. I'll just click on new and select a blank experiment, right? I will select a blank experiment, right? So I will have this option. Now I need to take my data set from offline to ML Azure, right? So I need to take it to the studio. So let me go to the data sets and then click on new. So it says upload a new data set from a local file. So I will have to upload the data set which I have downloaded here. So this is my actual data set. Right, so I'll just give a don't save, and from local file I will upload the data set. So let me just choose it and then let me go to downloads. I've got this as my data set, salary underscore data 1.csv. Right, so I hope you all also have this particular data set. Just click on open and then you can enter any name for the data set. Right, so I can give linear regression, or I can give regression analysis, or anything, right? So I'll just give regression analysis. And it is a CSV format. The file is in a CSV. Any optional description, you are good to go, and then you can give. Right, so this is salary underscore data dot CSV. And then I will give a OK. So it says uploading a new data set regression analysis in the bottom. So I hope you all will also have the same thing. Just go to data sets, click on new from local file, and then start uploading. So we've got regression analysis submitted by whatever is your username, and then it is a CSV, right? So this is the data set which we have. Now go back to your experiments and just create a new blank experiment, right? So we are creating a new blank experiment, and it says you need to drag and drop all your items from left onto the screen, right? So what you need to do is, first we'll name the experiment as salary versus years of experience, right? Or I can just give regression analysis. So this is what we call our experiment which we are doing right now. So it says to create our experiment, drag and drop data sets and modules here. So we know that we have uploaded one data set, so it should be in the save data sets part. So the things on the left are called as modules. We've got so many things. You can import data sets, you can import data and input and output. You can apply machine learning models, you can apply computer vision, Python language, R language, because these two are used for machine learning and data science, right? Statistical functions, text analytics, time series, web service, right? So we'll do the machine learning model here, that is linear regression first. So for that we need data, right? If you just have a look here, I can actually have an option which says my data sets, or also there are so many sample data sets which are available. We've got so many of the sample data sets, right? So I will take regression analysis data set. I will just drag and drop it here, right? So it says one and then regression analysis. So this is my data right here. How do I know that this is the same data which I uploaded? I can just right click and then I can go and click on visualize. Right? So it is giving me years of experience versus salary and giving me all the details. There were 30 rows inside it. There are 2 columns inside it, and then I've got all the values. These are all the statistics. The mean value of the years of experience, the median, the minimum value out of these things, the maximum value, the standard deviation, how many unique values are there, how many are repeated, and then how many missing values are there, and what is the feature. It is all numeric, so all numerical values. Same things for salary, mean, median, and minimum value, maximum value, the standard deviation, unique values, and then how many missing values are there, and what is the feature. Again, it is numerical value. Right? So you can also have the graphs. you can compare the histogram which you got. Just a second. Okay, please just give me 1 minute. There is some problem in viewing the screen. I'll just make sure that that does not happen. Okay, so I hope now it's good to go. Yeah. So what I'm doing is I've got all the visuals of all the graphs. I've got a histogram here for years of experience against the frequency, and then I can actually compare it with years of experience and then salary, right? So this is the value which we need. If you remember in the regression calculator, we had got all of these points, right, in terms of small yellow colored boxes. And using these values, we were actually trying to draw a best fit line, which came somewhat like this in blue color, right? So for this salary, we are trying to predict new values from our model, and then we will get the line or the dotted lines here. Right? So this is the data set which we have. Now this was the first step. After I do this, I need to add all the modules from my left hand side. I've got my data set. Now I have different functionalities which I can add. I can just drag and drop them, and then I need to connect them. Right? So it is like that. We'll just get started with it very quickly. It's not at all difficult. Okay. Now, what are we trying to do? We are trying to create a model to predict the salary of a person with a certain years of experience. Right? So for this, I need to have all the columns in the data set. So I'll just type for columns. I'll just type columns and then give enter. Right? So what is happening if I give columns? If I give columns, it is giving me an option telling so many things. What all things can be done in a column. So I will scroll down, and then I'll give select columns in a data set. It tells that select columns to include or exclude from a data set in any operation. Right? So this is what we want, because I've got the data set. I need to select the columns from the data set, that is my X and Y. Now, how easy is this? Just click on this and then drag and link it. Right? So this is how easy it is. You just have to click and drag so that it is connecting. Now what is happening? The columns are connected to the data set. Right? So it is just giving us an error for now because we need to do a few more steps. Right? So we have connected it, and we have connected the upper block with a connection. Right? So now what I need to do, I just need to go to the right side and then give launch column selector. Right? So I want you all to do this along with me. After you have put these two things and then connected it, just give launch column selector. And with rules, when you give select the columns, I will select all the columns and then include the two columns, that is years of experience as well as salary. Right? So I'll just give a OK. I'll just repeat what I did. You can see that the red color thing is not there anymore. So what I did was, after I added this, I went to the launch column selector because we need to include the values. I clicked on this. It was here. I went to with rules. I clicked on all columns. Include the column names with years of experience and salary. Give a OK. Right? So it is now taking these two columns from the data set, and it is selecting these two columns. Right? So this is what we actually wanted. We wanted X as well as Y. Right? So I've taken both of these things. Now next step is, because we are using linear regression here, I will just search for linear regression. I'll give linear regression. Just give a enter. You can find that inside the machine learning in the models, it is showing that in regression there are two types. It is just showing me the linear regression model. So what I need to do is I just need to drag and drop it here. So it says this is a linear regression model. And I'll put it a little bit to the side. Right. So if this is my linear regression model and I have got all my data and everything, I need to create a model or train a model after doing this. Right. How do I actually train the model? Right. So I will just show you one more thing here. The solution method, there are two types in linear regression also. One is the ordinary least squares method, which we have been discussing now. Another one is online gradient descent curve, right? So we are discussing the simple one, which is ordinary least squares. Right? So, and that the other thing is a little more complicated. So we'll just leave it at default, all the things on the right side. This is my linear regression model. Now coming to the next thing is we need to train our model. So I will just search for train model, give enter, right? In machine learning, in the training part, you've got an option to train the model, right? So here it is. Now there are so many dots which we need to connect, right? So one here, one is here, one is here, and then one we also have it here. And this is giving a value as required with the red dot because we have not yet connected it anywhere. I just follow what I do and how I actually connect it. Right. I will connect the columns in the data set and then give this as input data to train my model. Right. So I am giving salary and years of experience to my model to train it. And I am applying this algorithm to train the model. I am applying the linear regression algorithm, a linear regression model to actually train it. So let me just put it here like this. Right. So I've connected this part here and then I've connected this part here. Right. So this actually trains my model. I hope all the steps still here are clear. If not, you can actually ask me to repeat, right? I'll just take your queries also after this. So I've selected the model, input given for the train model, and then I've applied the algorithm called as linear regression. Now imagine in supervised learning, if it was the classification sort of a problem. Right. So if it was not regression and if it was classification, what should I have done? Instead of regression, I just had to search here for right. Instead of regression, I just had to search here classification, and then I would have so many other options. Whichever was the classifier I wanted, I can just put it here. Again, this is also in machine learning, right? So I wanted the regression. So I've selected linear regression. Right. After this, we've got just two more steps. After the train model, we need to find the score. That is what our model is going to give, right? So the score model is one more thing which I will just type here. So I'll just give score and then I'll give model, right? What does score model do? It scores a regression model, right? So this is somewhat like after creating my model, what happens? This is what happens. I will get the score model after creating my model and after training it. So till this step, we have finished creating our model. Here we'll try to see the score and then evaluate it, check its accuracy and other stuff, right? So to find the lines and other things. So I will connect this dot to score model like this. Right, so this dot I'm going to connect it here, and in my train model, since this red thing is there, I'll just give launch column selector. Right, in my train for my launch column selector, I will just give salary and then give a OK. Right, so it says selected columns is, or the column name is salary. And finally, in the score model, okay, finally, in the score model, what I need to do is I need to connect this to the select columns in dataset. Right, so this is the connection which I need to do. Right, so this is the connection which I need to do. Casey Das, please request you not to spam in the chat section. right? So only ask questions if you have any genuine doubts, right? So please don't spam in the chat, or else we will have to just remove those comments. Please don't do that. Okay, now that I've got the score model part of this, I just need to connect it for evaluation. I will take another thing called as evaluate. Right, so in machine learning, I've got another option called as evaluate model. Right, so I'll just drag and drop this part here as well. Right, I will evaluate the model. For evaluating, let me just connect it here. Okay. After my score model, I've got evaluate model. Right, that's all. That's all in our connections. This is how simple it is. Just by doing this, we are actually doing the machine learning algorithm. Yes. So score model and evaluate model and train model is all done. We will just save. We are done with our regression model. Now, after I save, I just have to click on run. Right? Let me just run. It will actually evaluate and check step by step. You see this thing. It will give a green if it is successful, or else it will give a red. So it's giving us tick marks. It is training the model. It has created the model. Now it is showing us the output, right? Score model, and then showing us the accuracy and whatever is the error which we are finding, right? So here is my model which is being created, right? The salary versus year of experience regression analysis model is ready. Now, even though it says it is ready, we haven't really got the output. Where can we see the output, right? Oh, okay. Before I go to that part, is it clear till here? Did you understand what I did in all of these steps? Can I just get a quick confirmation? Just respond with a yes if you have understood and if it was clear. Yes, okay. Right, others? Yes, Aishi also says yes, fine. Lata also says yes, others, good, okay. Right, so I hope it was not very difficult. I'm trying to make it very simple for you. Right, Vikram, Fatima all say yes, fine. Piyush Raj as well, yes. Right, okay, Manjunath, Pratham, Rohini, all of you, yes, yes, yes. Okay, no questions. Aman also says yes. Any questions? You are welcome to ask. Right, till here, up to this, right, I think there are no doubts. Now that we have got all of these things, is anybody willing to speak?
Hello, sir.
Yes, ma'am.
Sir, can I have one question, sir? I have.
Yes, ma'am.
Sir, actually, can we use this ML Azure is there, sir, for other type of analysis?
Yes, ma'am. We can go ahead and use. There are so many types which are available in here. And in fact, all of the machine learning models can be done here. Pretty much everything is here. We've got regression, clustering, classification, anomaly detection, right? So we've got so many options. You can just have a look here. All of these things can be used.
Okay, thank you, sir.
Okay, no problem. Right. Fine. So continuing with this, how to actually find the values and then know that our model is actually working, right? So what I'll do is I will click on score model, right? If you see here, there is something called as score model, right? We have just created a score model and now there is 1. I will just click on this number 1 and there is an option to visualize in the score model, right? So this is where we get our output, or I wouldn't say output, our train model with all the values and everything. So I'll just click on visualize. Okay, so what is it doing? It is taking us back to the same thing which we saw in the very first thing. When I clicked here and then clicked on visualize, I was getting rows 30, columns 2. Years was a salary, right? So what happened was when I click on scored model and visualize, it is showing me 3 columns. Years of experience, salary, and then one thing is extra called as scored labels. Now this is the values which is getting from our train model. This is the model which we just created and the values according to that model, right? So here are the values. Actual value of salary is 39,343. for 1.1 years of experience. But what did my machine learning model do? It is giving me 36,183 as the scored levels value. Right, so this is the value which it is giving, and then salary was supposed to be 46. This is what my model has predicted. So all of these are model predicted values. Right, so we know that it is not 100% accurate. One thing is very clear, right? So it is not 100% accurate, and for this we are almost getting 36 for 39, a 3k difference almost. Here there is around 5 or 6k difference in the values, right? So how we will see that is we'll try to compare it. Now scored labels are there in histogram. I'll just give salary. Salary, this is the initial thing which we found out, right? Which was there even in the beginning. Now I will compare it with scored labels. You can see that it is giving me a linear curve. It is giving me a straight line in the scored labels. Right? So we are not bothered about years of experience. We are bothered about scored labels because this is the model which we just created. Right, so it is giving me this particular linear curve. So if you just combine all the dots and then draw a straight line upon these dots, we get a straight line along with all of these dots. Right, so this is a way of visualizing the data in here. That is the scored labels. So these dot things in visualization, we call these as scatter plots. Right? Similarly, if I had it none, this is called as a histogram. So these are different types of plots which we can use for visualization. Right? So scored label values are here. Now again, I can also view it as a different type called as a box plot. Right? So if I just give a none, I've got a different type of a plot called as a box plot. Right? Similarly, for salary, it will just be a scatter plot as well as a scatter plot for this also. Right? So I've got a linear regression curve. So this is our regression analysis which we do, and here we get the values. Now coming to the final step, we'll try and evaluate our model. Right, I'll just go to evaluate model. I will click on 1 and then I will give visualize. Right, so what is happening here? It is giving us all the error and all the values. Now how is a model evaluated? Right? It says that this is the accuracy of my model, around 95%. And then for evaluation, we calculate the error. Depending on the error, we can actually get the value. So we use something called as mean squared error, right? And then there is also something called as mean absolute error. So I've got this mean squared error part of it in my PPT as well. So you can have a look at the formula to calculate the mean squared error. Imagine this is the actual formula. E is equal to 1 by n summation I is equal to 0 to n yi minus yi bar whole square. Right? So if yi is my actual value and yi bar is the predicted value, which is from my model, I'll just replace this in the next step with y is equal to mx plus c equation for yi bar, mxi plus c whole square equation. So if I put this particular formula and then evaluate all the values, this is the mean squared error value which I get. And then the accuracy is around 95%. We also have relative absolute error. We also have relative squared error, but then we just want this particular error value. Right? So for 95% accuracy, these are all the other metrics. Right? So they've also put in an error histogram for each value which is here for our analysis. Right? So this is where we can actually evaluate and check the values of our model. Right? Here it is. This is your linear regression. And this finishes our creating a linear regression model without even one line of code. There is absolutely no code in here. Right? Let me just save this. If I want, this is my experiment. I can also add it to a project of mine. Say if I just did this, I can just click on add to project, and then I've got one folder there, so I can just add it to this folder. So in projects, first you need to create a project. I've got one. I can just put it in here. Right? So you can actually store and then explore different things in your ML Azure Studio as well. Right. Now, coming to the real world application of where we use this regression and why did we learn all the maths behind it and where is it applied, right? So I'll show you one simple example, very common example. And so there is this website called as Cars24. I think you all are aware about this thing, or at least a similar type of a platform, right? So it's an online used car marketplace, right? So they sell cars taking from different buyers, and if I want, I can actually go and buy a car online on Cars24, right? So I can either buy or sell. So that is the thing. So it's basically an online platform. Now, okay, you might be wondering why I'm telling all this. I'll just explain it to you in a minute. Let me go inside this cars24.com website, and here it is. So imagine I want to sell a car, right? So we'll just try to sell a car. Say I've got a Mercedes, right? It is next. It is asking me all the parameters. Like that is, it is asking me which is your car model, which is the brand. Brand is Mercedes Benz. Car model. Say I've got a S class. It is asking me what is the registration year, right? So I'll give 2018. It is asking me what is the fuel type, right? Let it be anything, petrol or diesel, right? There is one variant. It is asking me which is the variant, right? So S350 CDI, and which is the state of your registration, your car's registration, right? So let me just search for KA. KA is Karnataka. Then select the RTO code and all of these things. Say, let me just give KA05, anything, right? So it took all of these details, and it says just one more step to get the car price. Now, what all things is happening? It has taken all the inputs. What is my car type? I gave it Mercedes Benz. What is the model type? S class. What is the year of manufacturing? What is the registration? Which is the RTO? Which is the model? What is the fuel type? So it took all of these input parameters, right? For example, if I just say open my data set, just a minute. In here, we had just one parameter. According to years of experience, we had salary. Now, in this case, we have car, we have model, then we have registration, then we have fuel type, then we also have class or brand. Right? So brand. Then finally, it is telling that it will evaluate the price. So here it was just X and Y, but now it is all of these things are X. Taking into consideration for all of these values, my price is given. Say it is going to cost me somewhere around 55 lakhs. I think this is 55,000, right? So somewhere around 55 lakhs is the worth of that Mercedes Benz car, whichever I saw. Right? I'm not sure. I'm just giving some value, which I just assumed. Right? For some other vehicle, it is giving me somewhere around 30 lakhs. Right? For some other vehicle, 10 lakhs. Right? How is it able to actually give all of these values according to the inputs which we have? And then we will have one more thing called as scored labels or final output, wherein our model will actually estimate if it's got 53,000 or not. Now, what is happening in this Cars24? After taking all of these values into consideration, it is giving me the price. Right? So it is giving me the scored label. Right? It is telling me as soon as I enter my mobile number, I will get the car price. So this is the predicted car price which they have used. So they have used a linear regression model, but instead of one parameter, they have used so many other things. Like I just told you all the examples. Right? So all of these things are used, and then you will get your car price. So this is a perfect example for the regression and then linear regression analysis, which is done in here. Like in our daily lives, we can actually go ahead and use this. This is where it is used. Right. Okay. Do we have any questions? If you have, please do comment in the chat box, or else you can just put in no issues or no questions. Right. So that I'll just go ahead. Okay, perfect. No issues. Fine. So we actually saw two different methods. One thing is we went into spreadsheet. We actually did all the math ourselves, right? And then we got all the values. Another thing is we went to the calculator online, and from there also we got the values. And then we actually created a model here in the ML Azure Studio. Now, I will actually show you a little bit of Python as well, right? So I'll show you a proper example. Like using this ML Azure Studio, I could not find the M value or C value, right? So all of those things were not found. Now there is one thing in Python which I can do. Right, I'll just show you that thing also. Okay, I will be opening one more online cloud platform called as Google Collaboratory. Right, so this is basically a editor for doing all of our machine learning or linear regression models, right? So I've got one thing here. This is the actual method using Python to perform a machine learning algorithm, right? So all this while we've been doing all these shortcuts, and then we've been doing it in very simple steps without any code. So the same thing, if you want it with the code, I will also show you this thing. I'm not going to type the code or make you type or anything. This is just a demo, right? So this is just for you to get a better understanding about all the maths that we have done, right? So this is a library in Python. The language used here is Python. Import pandas. Pandas is a library. And then you can just see that I've used the same CSV or same data set. Correct? This is my X, this is my Y, and then I've got all the same data. Now I will take the input and output separately for X and Y. So we use something called as df.ilog, right? You need not worry about all of those things. Right? I've got X and Y. Just consider that this is input and this is output. Now, we've got one more thing called as, one more package called as sklearn. In that, there is linear regression, right? Somewhat like how we had all the modules and everything in ML Azure, we've got something called as sklearn. From here, also we can find linear regression, your classification, your clusterer, and all of the other things. Right? So all of those things are available. So I will import linear regression part from here. Again, I put the same steps. I need to select the algorithm, if it's linear regression or not. I need to create a model, which is fitting the model, called here as fit. Then I will predict the new output. And then finally, I'll find its accuracy or evaluate it. Right? So this part, you will understand it better here. Right? So there are a few steps which I actually need to use. So let me just give model equals to linear regression, and then model.fit, which means that I am actually creating a model, right? After doing all the training and everything, I'm actually creating a model, right? So after that, I'm giving it values to actually try and predict, right? So it is giving me something called as predicted output. Okay, so I've got predicted output in here, and then it is giving us all the values, right? So if you just try and compare this, 36,187. So I will also show you the real output. Right. So it was supposed to be 39343 and 46205. Let me just copy these three things and paste it here. Like, okay, in the thing which we just did. And I will go to run, or I'll just go to visualize in the score model. Right, so it was 39343, and then I've got 36183, right? 39343 and 36187 is what I've got, right? So this model is slightly better because we are using a different approach. Now 46205 and 38007. 46,205, 38074 instead of 077, right? So slight differences, almost same. So the difference in the accuracy and everything when we use different methods is almost like 95% accuracy which we got, right? So we can just try and compare all of the 30 values here with the 30 values here. Now coming to the part of coefficient, that is slope. Right here, M is slope of line. We can directly get it from sklearn without doing any calculation. It will give us directly the value of 9449.9623. Right? If I just go here and confirm, it is 9449.962321. 9449 plus 0.962321. Right? And sklearn is a lot more accurate. It is giving me another 2 decimal places extra. Right? So model.coefficient from sklearn in my Python is much more accurate. Similarly, I also get the intercept value as 25792. Same way here, C value 25792. 0.2002 was that. Here we have got so many other values also. It is so much more accurate. Right. One thing which was not possible there is if I want for a certain years of experience, say if I want a person with 6.5 years of experience to see how much is his or her salary, 87216. So directly from model.predict, I can give this particular value. I can also change this to 1.3 or 1.5 or 1.6, whichever value is not there in the data also I can actually take. So for 6.5, it is estimated that he or she should earn around 87,216. How did we get this 87? I just put it in the y is equal to mx plus c equation, right? So if this is my m, I'll just put it here, m into x, and then I've got plus, and then this is c. So here it is. I've put it into y is equal to mx plus c equation. Right? Since I've put it in y is equal to mx plus c equation, I am getting this output. So here is the proof. Using the same m, same c value, I just change the x value. And then I will get it here. Now coming to the final graph or the final line which I have, we call it as the best fit line. And so I hope you remember these dots which were being shown here. Right? So these dots which were being shown here when I gave the salary. You could have seen all of these points, right? And I told that it is a scatter plot. How did the scatter plot come? Here. We have a library called as matplotlib for plotting or visualization. In that we have got scatter plot. Right? So I've just plotted the original or actual points, and here for our predicted values, it was just giving us dots again, but I've put a proper line. So I've given a predicted line. Right? So this visualization is somewhat like your matplotlib, or sorry, the MATLAB software which we have used. A few of us might have used the MATLAB software. Most of us no. Don't worry, you will learn about that also if you have not learned. So this is the best fit line or the linear regression line which we are getting. Right? So using all the Python commands and actual programming, this is how we do it. Right? So how do I actually find the mean square error? Right, I will show you this also. Example, I take a few values, 123, 147, 122 and 178. Right, so these are a few values, say example. And after creating my model is giving me these values, 120, 150, 125 and 180. Right, so we know that this is not 100% accurate. These values are not as same as these. And there is some difference. So maybe 95% accuracy, 94% accuracy or something. So this is 3 difference. It was supposed to be 3 more. Here it was supposed to be 3 less. Again 3 less and then 2 less. Right? So we've got a difference here. Now how do I actually find the error? I subtract my actual value minus my predicted value. Right, so I've used another library here, y real minus y predicted. After subtracting it, I square to remove all the negative values. So I'll just take one example. Say if I subtract 123 minus 120, what happens? I get 3. Right, so this is the error value which I got. Now I will square this error. What is 3 square? So I'll just put it like this. 3 into 3. So I'm getting 9 as my value. Right, so I've got the square. And then I will find the mean for all of these values. Say if I take for this also 9 and then 9 and then this value. So I will get mean squared error, finding the mean of all of these values. So I've just showed you one example here as to what happens. Right, so this was just an example. So this is the mean squared error value which we got, which was similar to the thing we got here. When I did this, I actually got the mean squared error value, right? So the root mean squared value is again for all of the values. Now, we can also find the same thing, mean squared error for my data set, right? Here it is. You can see that the mean squared error value was 312,70951. Here it was, right, so this was for a single value, I think. It is giving somewhere around 5,592. Right, so according to this particular sklearn thing, I've got this as my mean squared error. And my accuracy almost I've got 95.69%. Here, 95.69% is what I've got. Right, so this is the total value, and then this is my 95.69% the accuracy value which I've got. So I've just shown you all the evaluation, all the things, and how to visualize how we got the M and C values, and then how we actually created this linear regression model and all of the analysis, everything. Right, so this is our complete linear regression analysis which I just showed. Right, so here we are. Okay, that's all. That is what I had to actually explain. Right, let me just stop this for a minute. Right, now we are open for questions. Any questions which you have, more than welcome to ask.
Hello, sir.
Yes, ma'am.
Sir, I have two questions.
Yes.
Sir, can you suggest some best tool to clean the data, sir?
Okay, for cleaning the data, if you are going to use Python programming, then yes, I've got another example here. Right, so this was for that example which I gave you for the car and all the specifications, right? So I told you how to predict the prices of cars. So here we have got something called as, let me just come down here and then I'll show you data cleaning. Right, we have to select the data types and then we have to use something called as cars numeric dot drop. Right, so we actually clean the data by removing the values specifically. Whichever value we want, we can remove the values. Right, so there is something called as drop NA or numeric dot drop. This is the thing which we need to use. And okay, I think my screen is not visible. Just give me a moment. Okay, right here. Here, if you just have a look, I told you about the car price prediction, right? Along with all the different things. Here there is an example for one of the cars here, car price assignment, and then at the end, there is the price. So we are trying to predict the prices and then all the values. So for dropping the values, I would suggest that you can just use this data cleaning and then taking only specific values. You can just use select data types, or after this, how to drop is you can use cars numeric dot drop, or there is one more thing called as drop NA. You can just have a look about what is drop NA and then you can actually go ahead. Even in this part, we can drop the values. Right, so there is an option here as well, data clean. It says clean missing data. This part is also available. Specifies how to handle the missing values from a data set. We can also do this. If it finds a missing value, what all things it should do. you can either replace that value with a custom value, you can replace that missing value with mean, median, mode, or you can entirely delete the row or delete the column, or you can do so many things. You can directly clean the missing data. So I just have to put this here and connect it to my data set. But since in our example there was no missing data, we did not use that. But yeah, this is an option. I think that should clear your doubt.
Yeah, thank you, sir. Sir, last question.
Yeah.
Sir, is there any option to get the code from ML Azure, sir?
For this, if you're speaking, right?
Yes, sir.
No, since we haven't really used any code, I don't think there is any. You can't directly get the code because it's just like flowcharts and then drag and drop. I understand what you're saying. Like in other platforms,
Yes, sir.
you can actually convert the code from this part of it, but I don't think that's possible here.
Okay, sir. Thank you, sir. Thank you very much.
Thank you. Yeah. Right. Okay, so does machine learning algorithms make decision in real time? Yes, it does, because I just showed you one example of CAST24. They are using the same linear regression analysis. Right, so yes, it does. There are various applications. Okay, what is basically the use of today's webinar as a first year student, and what all info from this webinar can I focus on? Right, so one thing I would just like to clear out is people have the wrong assumption telling that machine learning and artificial intelligence or data science, all of these things are restricted to computer science. It's totally wrong as of today's current world scenario, because all of us require these things. It's not necessary that only a computer science engineer or an ISC student has to learn this, right? So a triple E department student or a EC or some other branch, right? So anyone can actually go ahead and use this, because somewhere at some point we will actually be using this. So if your interest is there in machine learning or deep learning or doing something like object detection and all those things, you cannot just restrict it to computer science. So there is a link of all of these things. Like I showed you in my very first slides, there is a lot of mathematics involved in every single algorithm, right? So maths and stats are the base. Any algorithm you take, there will be numbers, there will be all the concepts which you learn. Like for example, if I take in clustering, we have got one thing called as k-means clustering. So there we need to find the k values, and then we will come across something called as Euclidean method, right? So distance formula, section formula, all of those things are very much required. So it's not like you have to restrict yourself, right? And it's also not like only CS people can do. And what are the things you can actually focus on here? Right, so if you're very much interested in this, so this should be somewhat like a jump start for you, a platform for you to build on. You have learned one algorithm thoroughly in depth, right? So you can just explore many other algorithms which are there, right? In fact, I will just show you one thing. So we are basically, we have a YouTube channel, Diazonic Labs. And then this particular webinar was hosted in association with Sir MVIT, specifically Department of Mathematics. And first thing is, I would ask you to consider subscribing to our channel if you have liked our session. And we have got you so many videos. That is, everything you need to know about Python basics is here. If you are interested in learning machine learning and all of these algorithms also, we've got so many other series. We've got Python tutorial series, right? So we've got so many webinars which we have already hosted. In that also, you can actually find. See here, we've got Introduction to Artificial Intelligence webinar. Then we've got things related to computer vision, end-to-end machine learning projects like live project we have done and then shown it online. Then for data visualization, I told you about Matplotlib, right? So there is another library here. So we have got so many videos and then playlist of all the other things. Data analysis using Python, right? So even that part is there. machine learning basics 101. You can probably go and check this out. I would actually refer you this particular thing. In fact, you can just go ahead and explore our YouTube channel. We've got loads of educational content for you all. You can just go ahead and have a look here. And I'll just share this link also with you in here. Yeah. Okay. One more question. What are the ethical implications of using this machine learning part? Right. So ethical implications, can you just be a little more specific as to what are things? Right. So I don't think you have any restrictions as such, because all of these are open source and anyone and everyone can actually use it. Right. So you need not worry about anything that you're going to do wrong or anything. Right, so it's all open source, and basically there are projects and algorithms which you can find directly on Google, so there is no problem as such. Right. While doing a PGs, which university will be the best for doing these types of courses? Okay. Right. Now upcoming, there are many universities. Like very recently, there is this thing in MIT. I think for MTech, there is specifically something for statistical learning and machine learning or AI also, right? So that is having a great scope. And then there are various other universities. So I think MIT is one of the best, not the Massachusetts one, the Manipal, right? So we are in India. We just come down a little bit, not going that. So Manipal Institute is having a really good thing for one of these courses. Others, there are many. Right. Okay. Now, yeah, I'll just wait. If you have a few more queries, I'll just be on mute for 2 minutes. Okay, I'm assuming that none of you have any questions or any queries. Right now, coming to the feedback forms and certificates and all of those things. Right. Firstly, I hope you all are there in the WhatsApp groups. Right. So if not, just request you to join the WhatsApp groups. The link was already mentioned or shared with you. I think there are participants there already. Okay, so we've got one group, one WhatsApp group, which has almost like reached the maximum number of participants. So I'll do one thing. I have got another WhatsApp group, and I will share the link only for those who have not joined the previous group, right? So only those people who have not joined the previous group, I want you all to join this group, right? So I want you all to join this WhatsApp group. Why am I doing this? Because your certificates will be updated in the WhatsApp group. So the link and everything will be updated in the WhatsApp group. So I want you all to join that. And I'll just share with you the link. Just give me a moment. Give me 1 minute. And I'm just trying to share the link of that. This is specifically only for those who have not joined the previous group. Please don't rejoin again. Okay. Here is the link. Right? Those who have not joined, can just join this particular WhatsApp group, because we will be updating our certificates here, and I will also share with you the feedback form link. Right, so I will tell you how you actually need to fill your feedback. Right, so here is the feedback form link. In fact, I will put up this feedback form link inside the WhatsApp group as well, right? So that you will find it easy. And we follow a slightly different procedure in taking our feedback. Just hear me out for say 2-3 minutes, because you will not be able to fill the feedback forms as of yet. Right? I will tell you what you need to do. Just click on this thing and right, okay. Here. Okay, so this is the feedback form. Now to give your session feedback, you will just have to visit one of the links which I've put in here. Right, so there is a tinyurl.com and then Revo Amel. So whatever you like from our session, like session summary or whatever were the nice things you like, if you like say ML Azure part of it, just put it there. If you like whatever was being taught to you and the way the session was hosted, right, you can just give us 5 stars, right? So, and then mention whatever comments you have about us. Yes, Mohini, I will just do that also. Please, please give me a minute. Piyush, no problem. Just wait. Right. I would request you to actually join the WhatsApp group. That would be better. Right. So, request you to open this particular URL from this, and then you need to join the WhatsApp group if you have not joined. Right. So, only if you have not joined, right? So this is going to be the group 2, because there is already one group, right? I was just giving you instructions because I've not yet started accepting responses, right? So only if you have not joined, you have to join this chat WhatsApp group, or else need not do it, right? Now, what all things? We will require your email, we will require the name, what you have, also your WhatsApp number, right? Then you just have to open the link, tiny URL, and fill the Google review, right? And give a yes once you fill the Google review. Also, please share the screenshot of whatever is the review you have given. And then we have got some other queries for you, 1 or 2 optional things, right? So if you are interested in letting us know anything, you can just put it here, right? So now coming to this link, I will tell you just one last thing, and then I will start accepting the responses. Right, so here, this is what you get. You will have the option for reviewing. You can give whatever is the details, right? So summary, I like this part, I like the ML part, and then this is what was nice, right? So you can give whatever it is, and then take a screenshot of this particular thing after you post, right? Say post it, and then you can actually take a screenshot of your rating and attach that same thing in the feedback form, right? So this is one mandatory thing. I'm just asking you one thing. One mandatory thing is this: we just want the Google review from you all. Do that, attach the screenshot, and then just submit the form, right? And after we get all the responses, say in a few hours, 2 or 3 hours, we'll actually process, and then say after some time, we will give you an update as to when the certificates will be issued in the WhatsApp group, right? So again, if you want your certificates, you have to join the WhatsApp group. If you've already joined, no problems, or else you have a link here, join this, and then, yeah, we'll process your certificates. And I'll also add this thing. Sorry, it was the WhatsApp group. Now I'll open the feedback form for responses. Make sure you do it in the next 15-20 minutes, right? Because we won't be keeping it open for long. Join this group. I will also put up a message at the end. And I hope you all have got this thing. I'll start accepting the responses now. And in fact, I'll reshare you the link. I think now the links will be open. Yes, okay, I'm just sharing it on the YouTube, this thing as well. Right, please make sure that you give the Google review and attach that same screenshot, or else you might have issues with finding the e-certificates, right? So your certificates, you might not actually find it. Please make sure that you do that. And yeah, thank you very much for attending. I would like to give the control to Vasudha ma'am, who will be giving you the rest of the things. We'll just proceed. Thank you, ma'am.
Thank you, Arif. It was a very good session, hands-on session, because many students were very interested, and it was a very good insight towards applications of mathematics in regression analysis. Okay, thank you very much. And now I request Vasudha, Assistant Professor, Department of Mathematics, to propose the vote of thanks for the day.
Good afternoon, everyone. It's my privilege to propose a vote of thanks speech. Myself, Vasudha, Assistant Professor, Department of Mathematics, RMVIT. First of all, extend my most sincere thanks to the Almighty God for making today's event a resounding success. With His blessings and grace, we are able to make this event what it was. On behalf of the Department of Mathematics, I extend really hearty vote of thanks to our principal, Dr. V.R. Manjunath sir, who gave permission to organize this webinar. I would like to thank our HOD, Dr. S.K. Mama, for her guidance and support to conduct such an interactive session. I'm immensely thankful to our speaker, Mr. Arif Nawaz, lead technical trainer, Diazonic Labs, who spared time from his busiest schedule. Today, we had an opportunity to hear your wonderful thoughts, and this will surely be going to encourage our students in future. I would like to thank our coordinator, Chaya ma'am, for her efforts and everything on this event. I also extend thanks to all the faculty members of our department for their presence. Finally, I would like to thank our budding rock stars that made this event successful with their impressive presence and performances. Last but not least, a big thank you to each one of you who made this event successful for all of us. Thank you.
Yeah, thank you, Vasudha. So, guys, now we are signing off from the webinar, and thank you everyone for attending the inquiry regarding the certificates. Please wait for some 3 to 4 hours. We will be available with the certificates for you guys. Thank you, guys. You guys can sign off now.
Thank you, ma'am. I have also posted the link to join the WhatsApp group in the YouTube for people watching us on YouTube. Right. So I've just given you the link. Join the WhatsApp group, and I've just posted the feedback form there. Right. The link is not taking responses. Okay, I think it's perfectly all right now. Right. If you have any queries, you can just reach out to the admins of the WhatsApp group, and then we'll solve your queries there. Right. So people who are watching us from YouTube, I think this should help you. Just join that WhatsApp group and then give me a confirmation so that we'll actually end the session here. Right. So thank you all for attending. Stay safe.